So in this video, we're going to learn about a new concept this year, which is called domain and range. So domain and range are two separate but somewhat related ideas. So the domain is something that describes all the possible values of the independent variable in a relationship. And we'll get to that more in a second. And the range describes all the possible dependent variable values, or all the possible values of the dv. So when you're describing the domain and range, there's two main things you need to consider. The first thing is the type of number that represents that particular variable. So for example, real numbers, integers, etc. So can you have decimals? Are you limited to positive and negative whole numbers? Things like that. The second thing you have to take into consideration are any restrictions on the values. And this usually manifests as sort of maximum and or minimum values. So when we're describing domain and range, we're going to keep in mind these two main ideas. So we're going to describe the domain and range for the two graphs that we see below. So in the first graph here on the left, for the domain, we're dealing with the IV, which in this case is number of years, okay, or amount of time that has passed since 1996. So let's call that T as it's been defined in the graph for us. So when we think about type of number, T or time is going to be a real number because you can have decimals. So for example, you could have 1.5 years since 1996, and that's okay. So you're not limited to just whole numbers. However, T has to be greater than or equal to 0. Because as you look on the graph begins when t equals 0. So we can't have negative numbers for t, but we can have decimals. So we're specifying those two ideas there. Real number, greater than or equal to 0. For the range, in this particular graph, range is your dependent variable, which in this case is number of households. And here, the units are important to keep in mind. So keep in mind this is measured in millions of households, and our variable here is h. So as you can see from the points on the graph, you can still have decimals. For example, 21.66 would be 21,660,000. So again, h is a real number, so you can have decimals in there as well. But if you look at the starting point of the graph, what's really important is it starts at 14.9. So when we're looking at that information, we know that h is greater than or equal to 14.9 million, because again, that's the unit of measurement here. So 14.9 million households. So here we've defined the domain and range by looking at the type of number for each variable and for the restrictions that might exist on it. So when we look at the next graph, that's an interesting one because the domain here, we don't have a real life situation. So the domain is just x, and that's on the horizontal axis. And if you look at the line, it encompasses all values, so decimals, negatives, positives, and the arrows indicate that the line continues in both directions. So x is any real number. And we don't have to write anything else for the domain because there are no restrictions. There's no maximum, there's no minimum. This line extends forever and ever. So the only thing we have to specify for the domain here is that x is any real number. Similarly, for the range, that's the variable y. And again, because the y values can go in any direction, imagine if that line extended infinitely, it would become infinitely wide across the x-axis and infinitely tall across the y-axis. So we just have to specify that y is any real number. So it includes decimals, fractions, pi, negatives, positives, all those things. So when you're observing or investigating domain and range, you're interested in looking at the type of number for each variable, domain being the independent variable, range being the dependent variable, and any restrictions that might exist on those values.